Okay, so problem 3 is very similar to problem 1. So let's just read it. On the day when the temperature is 20 degrees C, a concrete walk is poured in such a way that its ends are unable to move. So it means it's restrained, but it's not under stress at that point. What is the stress in the cement when its temperature is 50 degrees C on a hot sunny day? Does the concrete fracture? So in this case, what we can do is we can, again, look at the change in length of the concrete. It's going to, due to the temperature change, is alpha times delta T times the original length. So the original length is, well, actually, I don't tell you what that is, but that's okay. So we're actually going to calculate delta L over L 0. And that's going to be equal to alpha for concrete, which is, well, let me just write out the equation. So it's just delta T times alpha times delta T. So alpha is, okay, so we're going to have to find what is alpha for concrete. Okay. And I don't see it in the new book, so I'm going to get the old book. If I can find my old book. Oh, there it is. So let me look in the old book. So it's chapter 10 in the old book. Average coefficients of expansion concrete. Well, 12 times 10 to the minus 6. 12 times 10 to the minus 6. The units are 1 over degrees C times the temperature change, which is 30 degrees C, and it's going to expand, or it wants to expand, but it can't expand because it's restrained. So as a consequence, it's going to be put under compression. So we get 12 e to the minus 6 times 30. And so the change in length divided by L0 is 3.6 times 10 to the minus 4 meters per meter in this case. So now we go to the other expression we were using, was the stress was equal to E divided by times epsilon. But epsilon is this thing right here. So we can calculate the stress in the concrete by taking Young's modulus, which is 7 times 10 to the 9th newtons per meter squared, multiplied by epsilon, which is delta L over L 0, 3.4 times 10 to the minus 4 meters per meter. And so this is stress the same as the units for Young's modulus. So 7 times 10 to the 9th times 3.6 e to the minus 4. And I get 2.5 times 10 to the 6 newtons per meter squared. Is that right? 1, 2, 3, 4, 5, 6. Now the compressive strength is 2 times 10 to the 7th. So because this is less than that, we should be okay. If this were greater than that, and I'm just making sure, we just check the answer here. Yeah, okay, so that's good. So this is the correct answer. So the answer to the first question, what is the stress? The stress is 2.5 times 10 to the 6 newtons per meter squared, or pascals. And because the stress is less than the compressive strength, then we say it doesn't fracture. It's not that close. It's almost off by a factor of 10. So she should feel pretty good about that.